Hello everyone. I hope you're doing well. As normal, what you need to do is get the notes from either from class or from Google Classroom or the packet that was given to you, and take notes along with me. Once you're finished, upload this document to Google Classroom and start in the exit slip. So today we're going to be talking about something called arithmetic sequences, and I know it may look like arithmetic, but the way the mathematicians pronounce it is a little bit weird. You can say arithmetic sequence, but I'm going to be saying arithmetic. So in order to begin, let's define this. So an arithmetic sequence is a sequence in which the difference between any two consecutive terms and by terms I mean numbers is constant. And this definition may not make sense yet, but once you start seeing the problems, it'll probably make a little bit more sense. Next, we need to define what the common difference is. So it's exactly as what it sounds. It's the numerical difference. And in this case, we're going to be using a lowercase d to represent it, between any two consecutive terms. So again, an arithmetic sequence is a sequence in which the difference between any two consecutive terms is constant, and the common difference is the numerical difference between any two consecutive terms. Let's move on to some examples. So with this, we are asked to determine whether the sequences are arithmetic, and if yes, we have to determine the common difference. So let's take a look at number 1. We have a sequence of 1, 5, 9, 13. We have to determine whether or not going from one number to the next is a constant. So in other words, it's always the same. You're doing the same thing to the number. And you're either adding or subtracting. You are able to do multiplication, but that's a completely different being. That's called a geometric sequence, and for right now we won't be covering those in this class. So number 1, we have 1, 5, 9, 13, and so on. So I'm going to ask to myself, how do I go from 1 to 5? Okay, well, I can add 4 to that. Now I'm going to check again, how do we go from, let's say, 9 to 13? We're adding 4. So going from one term to the next, we're always adding 4, it seems. So if we add 4, we go to 5. If we add 4, we go to 9, and if we add 4 again, we go to 13. So we can determine that yes, this is an arithmetic sequence, and the difference is 4. Okay? Let's look at number 2. So with this one, we have 1 to 3, 3 to 5, 5 to 8. Okay, so let's think about this a little bit. So how can we go from 1 to 3? Well, in order to do that, we can add 2. How do we go from 3 to 5? Well, we add 2. But how do we go from 5 to 8? We can't add 2 because that would give us 7. So instead we have to add 3. So since these numbers don't all match, we have to say that no, this is not an arithmetic sequence. Okay? Let's talk about number 3. We have 8, 6, 4, 2, etc. So how do we go from 8 to 6? Well, it looks like we can subtract 2. 6 to 4, subtract 2. 4 to 2, subtract 2. So it looks like we do have a common, a constant that's being subtracted. So we can say that yes, this is an arithmetic sequence, and the difference is, well, this time it's going to be negative 2, because the common difference, we have to think of it as we're always adding. So if you add a negative number, that's the same thing as subtraction. And if you add a positive number, that's just addition. Okay? So let's leave number 4, 5, and 6 for you to do on your own. I need you to determine if they are arithmetic sequences, and if they are, I need you to give me the common difference. Okay? If you have any problems with it, make sure that you message me on LifeGrades or text me, and just let me know what problems you're having issues with. So sometimes we're asked to continue the arithmetic sequence. So we're going to be using the same things that we did in the previous problems, where we have to determine the common difference. So with 7, 8, and 9, we're told that yes, this is an arithmetic sequence. So we have to determine what the common difference is. And then using the common difference, we have to determine what the 3 next terms would be in the sequence. So let's take a look at number 7. So this is an arithmetic sequence. We have to find the common difference, so in other words, D. So how do we go from 9 to 13? Well, we add 4. How do we go to 13 to 17? You also add 4. 17 to 21, you add 4. So with this, I can say that the common difference is 4. So what would be the next term, going from 21 to what? Well, if we add 4 to 21, we're going to get 25. If we add 4 to 25, we're going to get 29. And if we add 4 to 29, we're going to get 33. And right there, we have finished the arithmetic sequence that it's asking. We found the next 3 terms. Number 8, we have the sequence 5, 2, -1, -4. So what's happening with this? Whenever we go from 5 to 2, it looks like we are subtracting 3. Going from 2 to -1, subtracting 3 again. 1 to -4, we're subtracting 3. Now we have to continue this, so our common difference seems to be -3. So the next term after -4, well, in order to find that, we would just take -4 minus 3, and that would give us -7. And -7 minus 3, -10. -10 minus 3, -13. So that's our second sequence. Notice that we found the common difference, and we used the last term to determine the next 3 terms. I want you to try number 9 by yourself, and let's talk about the next part. So in the previous section, we talked about finding the next 3 terms. But what if I told you I want you to find the 99th term? That would be kind of hard, or it wouldn't be hard, it would just take you forever. So instead, we have a way to determine what the nth term, in other words, if I want to find the 99th term or the 115th term, whatever we want to find, there's a formula that we're able to use. And the formula that we're going to be utilizing is A sub n is equal to d parentheses n minus 1 plus a sub 1. And where n is equal to the position of the term. So in other words, if we want to find the 19th term, we would say n is equal to 19. And then we would change the n's into 19s, and so forth, continuing. So D stands for the common difference again. And in this case, a sub 1 is just the first term. So in general, the first term is usually given to you. Okay, so let's use the formula to help us determine well, it says to write the rule for the ninth term, or for the nth term. Let's go ahead and do that. We have a sub n is equal to d times n minus 1 plus a sub 1. And then we're asked to find a sub 19. So in other words, we're asked to find the 19th term. So for this problem, n is going to be equal to 19. So what we have to do is determine what the first term is. So in other words, a sub 1. And if we look in our sequence, the first term is 7. And the next thing we have to do is find the common difference. And looking at this, going from 7 to 13, what do? Well, we add 6. Going from 13 to 19, we add 6. Going from 19 to 25, we add 6. So I can say that the common difference is going to be 6. Next, we're going to substitute in everything that we need. So n is going to be changing into 19, a sub 1 is going to be changing into 7, and d is going to be changing into 6. So we have a sub 19 is equal to, d was equal to 6, times, in parentheses, n, which is 19, minus 1, plus a sub 1, which was 7. And now this is just a simple problem that we need to solve. Okay? So let's go ahead and do this. So we have 19 minus 1 inside the parentheses. That gives us 18. Plus 7. 6 times 18 is going to give us, 108. Yeah, 108 plus 7. And that gives us that a sub 19, or the 19th term, is equal to 115. So if I asked you to do that the other way, you'd have to add 6, another 15 times, or 18 times, whatever. It's going to take you a lot longer. So I want you to use the formula and try 11 by yourself. And whenever you do that, I want your problems to look exactly like number 10. So I need you to write, n is equal to blah. A sub 1 is equal to blah. D is equal to blah. And then start off by writing the formula. And then start working from there. So substitute everything in, solve it, and make sure that you put your final answer in a box. And let's move on to the second page. Okay, so on the second page, we're going to start off with number 12. We have the sequence -11, -8, -5, -2. And again, this goes on with the previous section, so we're having to find the 19th term. So our goal is to find the 19th term, so we're going to set n equal to 19. our first term, so a sub 1 is equal to negative 11. Let's go ahead and find the difference, the common difference. So going from negative 11 to negative 8, it looks like we are adding 3. From negative 8 to negative 5, we're going to be adding 3 again. And from negative 5 to negative 2, we add 3. So it looks like the common difference is going to be positive 3. Now, we're going to write down the formula for finding the nth term. So we have a sub n is equal to d multiplied by, in parentheses, n minus 1 plus a sub 1. We're going to plug everything in now. So we have a sub 19 is equal to d multiplied by n minus 1, so n was 19. Sorry, this d needs to be changed to a 3. Forgot to do that. So 19 minus 1 plus the first term, and the first term was negative 11. And now we solve this, so whatever's in the parentheses first. So we have 3 multiplied by 18. And if you add a negative, it's the same thing as subtracting, so we have minus 11. Next, we have 3 times 18, which gives us, excuse me, gives us, let's see, 3 times 18, that's going to be 30 plus 24, so 54 minus 11. And 54 minus 11 gives us 43. So 43 should be our 19th term. So remember to put your answer in a box. And there we go. I want you to try number 13 on your own. I also want you to try number 15 on your own. Let's do number 14 together. So we have the sequence negative 16, negative 21, negative 26, negative 31, and that continues on. So again, we're finding the 19th term, so n is going to be set equal to 19. The first term, or a sub 1, is equal to negative 16. And let's go ahead and find the common difference. So going from negative 16 to negative 21, it looks like we are subtracting 5. Going from negative 21 to negative 26, we're subtracting 5. And negative 26 to negative 31, we're subtracting 5. So it looks like our difference is going to be negative 5. Next, we have to write down the formula for finding the nth term. So we have a sub n is equal to d multiplied by the quantity of n minus 1 plus d. Or sorry, plus a1, a sub 1. Now, instead of substituting everything, let's leave in this, let's not substitute in yet. So, we have a sub n is equal to d, which is negative 5, multiplied by n minus 1, plus the first term, which is negative 16. And let's just distribute and simplify this a little bit. So we can distribute negative 5. So we have negative 5n. Negative 5 times negative 1 is going to be a positive 5, minus 16. If we combine like terms, we get negative 5n minus 11. So we're able to make this a little bit easier on ourselves, and this that I just circled is going to be the formula for this particular problem to find whatever number term we need. So since we need a 19th term, we can go ahead and sub in 19 for n. So we have a sub 19 is equal to negative 5 multiplied by 19 minus 11. Negative 5 multiplied by 19 is going to give us 95, negative 95, minus 11. And negative 95 minus 11 gives us negative 106. So we have that negative 106 is the 19th term for the sequence for number 14. And remember, I want you to try number 15 by yourself. So with the next two problems, we're going to be talking about like what applications we would be able to do. So, of course, whenever I say applications, that usually means a word problem. Let's go ahead and read the word problem. You visit the Grand Canyon and drop a penny off the edge of the cliff. The distance the penny will fall is 16 feet for the first second, 48 feet for the next second, 80 feet for the third second, and so on. So, of course, since we are on the packet for arithmetic sequences, let's try and find the arithmetic sequence. So, it looks like our very first thing that happens is the penny falls for 1 second. So the first second is 16 feet. The next second is 48 feet. The third second is 80 feet. Notice how this creates a sequence. And so on. So in other words, it just continues. So we now have our arithmetic sequence. So let's write the formula to represent the sequence. Notice that we're not asked to find what term yet. So we're not asked to find the 19th term. We're not asked to find the 15th term or whatever. It's just asking for a formula to represent the sequence. So that means that n is going to just stay as n. But we also have everything else. So the first term of the sequence is going to be 16. And the common difference. Let's try and figure that out. So how do we go from 16 to 48? Well, we can add 32. And going from 48 to 80, it looks like if we add 32 again, we get there. So our common difference is most likely going to be 32. Okay? Now, let's use the formula from before and create a new formula to represent this particular sequence. So we have a sub n is equal to d multiplied by n minus 1 plus a sub 1. Let's substitute everything other than n. So we have a sub n is equal to d, which is 32, multiplied by n minus 1 plus 16. Let's go ahead and distribute what we need to. So we have 32 multiplied by n. That gives us 32n. 32 multiplied by negative 1. That's negative 32. And then we have that plus 16. And finally, let's go ahead and combine like terms. So we have 32n. Negative 32 plus 16. That gives me a negative 16. So this right here is the formula that we need to determine whatever term we need. So this is the formula that's representing the sequence. Okay? Let's read part B. How far will the penny have traveled after 6 seconds? So in other words, what is the sixth term in the sequence? In order to find the sixth term, we just have to say, well, what happens whenever n is equal to 6? So a sub 6 is equal to 32 times 6 minus 16. And just remember that the reason that the 6's are there is I went up here, used this formula, and replaced the n's with 6's. And now I'm going to evaluate this. So 32 times 6, that's going to give me 192. And 192 minus 16 is going to give me 176. And for this problem, I want you to make sure that you include units. So what is this 176? Well, in this case, it would be feet. And that's going to be our answer. Okay? Now, let's move on to number 17. It says the total bank loan for Sarah's new car is $15,265. the bank automatically withdraws $295.80 each month to pay off the car. So, we have to first determine the sequence, but we don't have to determine the sequence in this one. We just have to figure out what the things are. So what would be the first term? So A sub 1. That's going to be after the first month has passed. So what's the balance of the loan? Well, for this case, it would be the $15,265 subtracted by the $295.80. So that gives me, like, you're making a payment. So after the first month, you've made a payment, and now this is the new balance. So the new balance should be $15,265 minus $295.8, which is going to give us $14,969.2. And then the common difference. So in other words, each month, what are they taking out from the bank? And if you read this problem, it says that the bank automatically withdraws $295.80. So withdrawal is usually a negative. So we're going to have negative $295.80 as our common difference for this sequence. Okay? So let's move on to trying to determine a formula to represent the sequence. So we're going to use that formula from before. So the A sub n is equal to D multiplied by n minus 1 plus A sub 1. And we're going to go ahead and substitute in A sub 1 and D. So we have A sub n is equal to D, which is negative 295.8 multiplied by n minus 1 plus A sub 1, which is 14,969.2. Okay? Now with this, we have to distribute and combine like terms. So let's go ahead and distribute first. So we have negative 295.8 multiplied by n. That gives me 295.8 n. And negative 295.8 multiplied by negative 1. That gives me a positive 295.8. Then we're going to add that 14,969.2. Moving on to the next line, we're going to combine like terms. So we have negative 295.8 n and 295.8 plus 14,969.2 is going to give us the original 15,265. So this right here is going to be the formula that represents the sequence. So let's move on to the next part. So what will the balance be after the loan, balance be of the loan after 2 years? So this is kind of a trick question because we're given years, but in the problem, it's months. So in other words, how many months are 2 years? And if you don't know that, get a calendar and count. So there's 12 months in a year, there's 2 years, so that means that we're going to be evaluating this for the 24th month. So in other words, we're going to set n equal to 24. Using the formula that we discovered before, we're going to take n and replace it with 24. So we have A sub 24 is equal to negative 295.8 multiplied by 24 plus 15,265. Okay? So after this, we just have to evaluate. So we're going to take the negative 295.8 multiplied by 24. I'm not doing that in my head, so let's get a calculator. So negative 295.8 multiplied by 24. That gives me negative 7,099.2, and we're adding 15,265 to that. after we add those two numbers together, so we have negative 7,099.2 plus 15,265. That gives us the new balance of the loan for $8,165.80. And since this is a word problem, I need units. So I'm going to put that dollar sign. So we have A sub 24 is equal to $8,165.80. So that's going to be the balance of the loan after 2 years. Now, this is it for the notes. If you're having any problems with it, note that I do have office hours on Wednesdays. The time varies because depending on what the school is having us do, we might be in meetings, we might be doing something else. But if you just pop on, see if I'm on. If I am in the room, like yell at me so I can know that you're actually there. But if you have any questions, feel free to ask me during class, text me, message me, do whatever you need to. And go ahead and submit this document to Google Classroom and go ahead and get started on the exit slip. Other than that, I hope you have a wonderful day, and I will see you next time.